Hello, Algebra 2. We've got a crunch course on factoring coming at you right now with all the different ways that we have factored so far throughout first quarter and all the ways that we are going to need to know how to factor for the rest of the year to make factoring a lot simpler for us. The first way that we talked about factoring was by finding a greatest common factor and factoring it out of whatever the polynomial was that we were looking at. So this is your greatest common factor. Okay? Remember, when you're factoring, you're doing the opposite of multiplying or simplifying. You are actually breaking it apart. So when we're looking at our first example, let's take a look at something that actually has several parts to it. 12x squared y to the fifth. I'm going to separate 12x squared y to the fifth with a plus sign. Anytime that you say a plus or a minus sign, that is going to separate your terms. So I know that I now have a second term, 6xy, and then minus 18x, no x, and we'll do y to the 8th. When we're looking for a greatest common factor, we're looking for a common number that multiplies to make any of the three terms that we are looking at. So when I look at 12, I'm trying to think, well, what makes 12? What could I multiply to make 12? What are the factors of 12? So I know 4 times 3 multiplies to make 12, so 4 and 3 are both factors of 12. 6 and 1 are both factors of 12. 12 is a factor of 12. Now let's look at 6. 2 and 3 multiply to make 6. 6 and 1 multiply to make 6. That's really all my choices. Look at 18. 9 times 2 makes 18. 6 times 3 makes 18. 1 times 18 makes 18. So now that I've named all these different numbers that multiply to make my three terms, what was the largest number that I said in all three terms? My hint, look at the smallest number we have, which is 6, right in the middle. I can't pick a number that's larger than 6, otherwise it wouldn't be common for all three of them. So is 6 a factor of all three terms? And yes, it does happen to be a factor of all three terms. I can make 6 part of my greatest common factor by pulling it out. Remember, 6 times 2 makes 12. 6 times 1 makes 6. 6 times 3 makes 18, so I know 6 works in all three terms. 6 alone, though, is not my greatest common factor. I also have to consider my x's and my y's. If I look across all three terms, again, look for the smallest x. I have 2 x's in the first term. I have 1 x in the second term. I have no x's in my last term. So is there an amount of x's that I can actually factor out of all three? No, because the 18y to the 8th, that last term, doesn't have any x's. So I can't take out the x. Now I'm going to consider the y's. I have 5 y's in the first term, 1 y in the second term, 8 y's in the last term. The most I can take out is only 1, because that middle term only has 1. I have now identified the 6y to be my GCF, my greatest common factor. Once you guys identify your GCF, we are going to factor it out, and we have to put the leftovers. What do I have to still multiply by to get back to my original? 6y multiplies by 2 to make 12. I need those x squared. I need 2 of the x's because I don't have any x's that I pulled out, factored out. And then I made 1 y factor out, and I have 5 total, so I still need 4. For my middle term, I factored out a 6, so really what I'm multiplying by is 1 here. I do need an x. I factored out a y, and I only had 1 y, so I'm good with my y's. I copy down the sign, the minus sign. 6 times 3 makes 18. I have already factored out 1 y. I have 8 total, so I need 7 more. I know that I factored this correctly because if I went back and I distributed my 6y to all three terms, I should end up with what I started with. So if I multiply 6y multiplied by 2x squared y to the 4th, I get the 12x to the 2nd y to the 5th. Remember, we add exponents when you multiply the bases. So y to the first power multiplied by y to the fourth power makes y to the fifth power, because I add the 1 plus the 4 to make the 5. 6y times 1x gives me 6yx, which is the same as 6xy. Because of the commutative property, I can write them in any order when I'm within one term, because they all multiply. And then 6y times 3, that gives me negative 18. I have 1y outside the parentheses, 7 on the inside, so I have a total of 8. These match, so I know I factored correctly. My final answer would be the 6y multiplied by everything inside the parentheses, because that was my factoring. I can't do anything else with what's left in the parentheses, because this one only had a greatest common factor. Let's look at another case when I factor trinomials. There are two different types of trinomials that I can factor. One is considering the a value equal to 1. So we did talk about the standard form of a trinomial, which is when you have ax squared, not a squared. You have ax squared. Try that one more time. Ax squared plus bx plus c. So again, the a, b's, and the c's are all just real numbers. They're coefficients for the x squared and the x term, and then the c is just a constant that we add on the end. We are going to go more into that in our next unit. But I wanted to talk about the a value, because when the a is 1, that means that you could have a problem where you have x squared plus 6x plus 5. Notice how the a value, so the number that's in front of the x squared, the coefficient for x squared, is just 1. So that makes it nice and easy, and all I need to do is think about this reverse FOIL. I'm going to reverse FOIL, so I'm going to think of what two binomials, factors, would multiply to make the x squared plus 6x plus 5. Remember, first times first makes first. So x times x, this first term, times the first term makes the first term. And then my last term times last term, last times last makes last. I also want my two last terms to add up to 6. So what two numbers multiply to make 5? 1 times 5 equals 5. And then I want those same two numbers to add up to make the 6 in the middle. So what I'm looking at here is that this product makes the last term, and the sum makes that term, the one in the middle. Okay? And I think I've got it. I think 5 and 1 work. They can both be positive, because positive 5 times positive 1 will make positive 5, and positive 1 plus positive 5 will make 6. I can also check by FOILing. And I should get back to where I started. Your second example is when your a value does not equal 1. So when you guys have, 4 a squared plus a minus 3. If you guys look at that a value, which is, our a value right now is 4. Remember that ax squared plus bx plus c is just representing what a standard trinomial looks like. However, I've switched my x's now to a's. Any variable will work. You're just looking at whatever variable is being squared or by itself, or then the last term doesn't have any variable whatsoever. So if I'm looking at 4a squared plus a minus 3, notice that the first number is a 4. It's not a 1 anymore. There's not an invisible 1 there. So this is called slide and divide. When I need to get rid of that 4, that's my coefficient. I really would rather factor without it there. So I'm going to slide it down so that I can factor without it and then put it back in later on. So slide and divide allows me to multiply the 4 times the last term, negative 3. That now removes the 4 from the first term, so all I have is a squared. My middle term does not change at all, and then my last term is now negative 12 because I multiplied 4 times negative 3. This allows me to factor like normal. So now I'm going to factor like I always have been doing, just like I did reverse FOIL up above. So first times first makes first, so I think a times a will make a squared. And then what two numbers multiply to make negative 12 and also add up to make a positive 1 in the middle? So 4 times 3 multiply to make 12. How can I use 4 and 3 to add up to a positive 1? That would be positive 4 and negative 3. This is great, I factored it, but my original problem had that 4 that I slid down. So if I slid this 4 down to multiply by the negative 3, I have to put it back in by dividing. Excuse me. So I always want to divide by what I slid by. Hence the name slide and divide. You have to slide it and you have to divide it later on. You always want to simplify once you divide again. So when I'm looking here, 3 divided by 4 does not simplify. It is already simplified. So that means my 4 is going to slide back in front of my a, and I now have 4a minus 3 as one of my factors. 4 divided by 4 does simplify. It makes 1, so a plus 1 is my other factor, and this is my final answer. If I want to check, I can FOIL, and I should wind up getting the same answer as what I started with. These are your trinomial cases. The last cases that we went over were your binomial cases. Binomial cases are when you have either a difference of squares, a sum of squares, a difference of cubes, or a sum of cubes. Now remember, this video is meant as a quick refresher because we have taken a lot of time to go over these notes already in class. So this is to remind you about all the different cases that we've learned together this year. A difference of squares, we have to make sure that we can identify, first of all, what a difference means. So the word difference, meaning you're going to have a subtraction symbol between two perfect squares. And a square means that one number multiplied by itself makes your perfect square. So if you have a perfect square, it has a square root that is a real number, a positive integer, basically. So I'm going to take my x squared is an example of a perfect square. 9 is an example of a perfect square. 3 times 3 equals 9. 3, 3. Same two integers multiplied by each other makes 9. X squared, x times x makes x squared. So a difference of squares, meaning you have a subtraction sign and you have two perfect squares on either side. Therefore, a sum of squares would be x squared plus 9. We talked about in class how if we have that plus sign in the middle, there's no way that we're going to not get a middle term if I write my factors for x squared and 9, x squared plus 9. Therefore, a sum of two perfect squares is always prime. A difference of two perfect squares I can factor by thinking about that reverse FOIL technique. First times first makes first. So x times x multiplies to make x squared. What two numbers multiply to make negative 9? Well, that would be negative 3 and positive 3. And then do negative 3 and positive 3 also add up to make nothing in the middle? Your middle term is a 0x, and they do. Therefore, that positive and negative 3 will cancel each other out and allow you to just have 2 terms instead of 3 terms. So x squared minus 9 factors into x minus 3, x